Supercharger Lift Assist project for Dr. John Mativa's 2130 Dynamics class with Ben Lane, Natalia Garcia, Brandon Bass, and Maleeka Zehra.
The Athens, Georgia Eaton Supercharger facility has two new product lines that require the addition of a Gorbel bridge and G-force lift assist. One product will use an end effector with a tare weight of 45 pounds and a capacity of 100 pounds, and the other has a tare weight of 178 pounds and capacity of 50 pounds. Assuming that cost and load ratings increase linearly, what model lift assist and load capacity bridge is most effective? The purpose of our project was to determine the most cost-effective lift assist and bridge in order to move the products given. The freestanding workstation needed to be able to move these products freely in order to enhance production. The freestanding workstation that fits Eaton's factory utilizes a 20-foot bridge span.
The design and method of our project was that we started by making a few assumptions. Movement is limited to the y-axis, and objects will be moved up and down a maximum of 5 feet. We then use kinematic equations. Vf squared is equal to vi squared plus 2a times delta x to find the maximum acceleration for each lift assist model and for each product. We assumed the 165-pound model wouldn't work because the load itself is heavier, so we only did calculations on the 330-pound and 660-pound models. By using the equation, sum of the forces is equal to ma, we were able to find the maximum force the freestanding workspace could hold. Using these results, we found the best workstation.
Here are the calculations of the method described in the previous slide. First, we calculated mass given the weight of each product. Then we assumed the average person had a reach of 4 feet. After finding the velocities from a chart on Gorbel's website, we plugged everything into the equation and solved for acceleration. We then used sum of the forces equals mass times acceleration to find the total force and compared that to the model. After repeating this process for each product and for each model, we can see that the 660-pound model is significantly greater than the forces we calculated, and the 330-pound model is only slightly greater. So the 330-pound model is the one that works best for us.
For our diagrams, we have a price versus G-force model capacity, which we used prices we found off of the G-force model capacity's website, and then compared them graphically. As you can see, it's generally a linear graph, which means that the price increases steadily as the capacity increases. We then have below it the diagram given to us by the G-force Gorbel website that has the maximum capacity and the maximum lifting speeds unloaded and fully loaded for each G-force model, which helped us in our calculations.
We discovered that the most optimal lift assist is the 330-pound capacity lift assist due to the calculations shown above. We also discovered that the most optimal workstation has a 500-pound capacity with a 20-foot length. Through this project, we were able to apply the knowledge gained in dynamics class and apply it to real-world situations. Working with a group also allowed us all to contribute and suggest new ideas. It also taught us how to make logical assumptions when we aren't given all the information necessary to solve the problem. We would recommend that the next group take a look at a problem like this first and try to think outside of the box on a solution, as the solution is not as cut and dry as normal problems are.